Some troubleshooting, repair, and service procedures for the QSK 45 and 60 engine require specialized service tools. Service tools used when working on the electronic control system include Insight for Quantum, QSK 4560 dyno controller, breakout cable kit, wiring harness kit, data link adapter. The use of some of these tools are covered in more detail in troubleshooting procedures in this section. Insight is a Windows-based software application that works with selected Cummins control modules to diagnose and troubleshoot engine problems, store and analyze historical information about an engine, and modify an engine's operating values. The dyno controller connects to the 21 and 31-pin OEM connectors to provide operator interface to operate the engine while it is on a dynamometer. 3 different style breakout cables connect between the sensors installed in the engine and the engine wiring harness connector. A breakout harness provides the ability to monitor the electrical circuit for these sensors. Each of the test leads is labeled or color-coded, corresponding with the pin to which they are connected. Refer to the wiring diagram for information about which pin is connected to each circuit. The wiring harness kit provides repair parts for wiring connections from the QSK 45 and 60 engine that are not found in the standard electrical wiring repair kit. An inline 1 data link adapter is needed to allow the ECM to communicate with Insight. In the future, an inline 2 adapter will work with Insight through the J1939 data link. The QSK 45 and 60 Quantum engine control system is a 24-volt system. In order to properly troubleshoot the control system, it is necessary to understand the various supply and operating voltages. The sensors within the system operate on a 5-volt supply signal. All of the switch circuits within the system are 12-volt circuits. Closing any of these switches causes the voltage in the circuit to be pulled to ground, indicating to the ECM that the switch has been closed and the appropriate action is requested. The one exception to this is the accelerator pedal. Both the idle-off-idle circuit and the position sensor circuit operate off of a 5-volt circuit. The PWM output is a 12-volt signal. All of the remaining output drivers create a 24-volt signal. Some of the features conflict with certain other features. This is often due to a shared pin in the ECM. Both the ether injection feature and the Sentinel makeup valve circuit utilize pin 2 on the engine harness connector. Due to this conflict with this pin, only one of these features can be enabled at one time. The third intermediate speed control speed cannot be utilized if intermediate speed control validation is desired. The second intermediate speed control speed cannot be utilized if a remote throttle select switch is desired. Because the OEM switch, cold idle inhibit, and frequency pull-up switches all use the same pin in the OEM harness connector, only one of these functions can be activated in the vehicle. The OEM switch is an optional switch that can be installed at the discretion of the vehicle OEM. When the cold idle inhibit switch is closed, the ECM operates the engine at the lower idle speed, even when operating in cold ambient conditions. When used for frequency pull-up, this circuit supplies a 12-volt supply source to a transistor. The switch connected to pin 36 in the OEM connector can be configured to operate as an alternate idle switch or as an auxiliary governor switch. The calibration will only allow the switch to function in one of these capacities. Whenever checking an electrical connection, the appropriate test lead must be used to avoid damaging the electrical component. When troubleshooting electrical components, similar types of procedures are normally followed. Although each of these steps cannot always be performed on each circuit, when they can be checked, these procedures verify if the circuit is performing properly. Check for the desired supply voltage to the component. Check for a short to ground. Check for a short from pin to pin in the connector. Check for an open circuit. And when possible, perform a function check of the component. A function check might consist of verifying component performance in specific circumstances. For example, checking a temperature sensor's resistance at a given temperature and comparing it to the manufacturer's specifications. For the electrical systems used on Cummins engines, a short to ground is typically defined as any connection with a resistance of less than 100 k ohms. An exception to this specification is the ESS short to ground, which is less than 10 mega ohms. A short circuit to an external voltage reading is more than 1.5 volts. For most circuits in the quantum electronic control system, the definition of a good closed circuit is less than 10 ohms. Therefore, an open circuit is more than 10 ohms. The QSK 45 and 60 wiring diagram provides information to assist you in understanding and troubleshooting the electrical system. This diagram shows the overall electrical system and will help you to identify circuits and individual pin labels. The wiring diagram also contains sensor specifications and a list of potential fault codes. A handheld tachometer can be used with this value set at 100% to determine the maximum fan speed. After determining the fan RPM at 100%, a lesser value can be entered and the RPM determined to verify that the fan is operating properly. The monitor screen displays calculated values from the signals supplied from various sensors in the system. This provides the ability to monitor engine operating conditions seen by the ECM. Sensor locations and a description of each sensor is covered in the engine controls familiarization portion of this program under Inputs. Specific fault code-driven trees are used when an active or inactive fault is logged. These trees apply specifically to an error logged by the ECM.